The other option, changing gravity. In Part 2, we explored the idea of dark matter, adding more mass to explain why galaxies hold together. That approach can explain some of what we observe, but it raises new questions about what that unseen mass is and how it behaves. So now we can ask a different question. What if the mass is already correct? What if the rules of gravity need to change? Newtonian gravity. Gravity gets weaker as you move farther away from a mass. The farther you go, the less pull you feel. And this follows a very specific pattern. The strength of gravity drops off with the square of the distance. So, if most of the mass is concentrated near the center of a galaxy, the pull at the outer edges should be much weaker. And that means stars at the outer edges should be moving more slowly. Where it breaks. But that's not what we observe. Stars at the outer edges of galaxies are still moving very fast. Much faster than Newtonian gravity predicts. The expected drop-off in gravity doesn't match what we see. So something in our model is not working. Either we're missing mass, or maybe we're missing something about how gravity behaves. Modified Newtonian gravity. MOND, or Modified Newtonian Dynamics, offers a different explanation. MOND proposes that the rules of gravity may change depending on distance. Close to the center of a galaxy, gravity follows the classical Newtonian formula. But farther out, instead of fading quickly, gravity appears to stay stronger over longer distances. To match what we observe, the Newtonian formula has to be modified in those outer regions. So instead of adding more mass, MOND describes a non-Newtonian pattern in how gravity behaves. A two-stage gravity rule. In Newtonian gravity, the pull drops off quickly with distance. But in MOND, that drop-off becomes slower in the outer regions. In the inner regions, gravity follows a square of the distance drop. But in the outer regions, MOND proposes a second stage, closer to a simple linear drop with distance. That means gravity would stay stronger farther out than the Newtonian model predicts. And that extra pull would be enough to keep those outer stars in stable, higher energy orbits. MOND is a limited fix. MOND can explain why stars at the edges of galaxies keep moving as fast as they do. But galaxies show more than just rotation. They are complex systems that persist over time. So in the next part, we step back and look at the bigger picture. We'll explore the full set of features that must be explained and get a better sense of the true scope of the problem.